In this lesson video, we are going to learn the basics of point-to-point modeling. So what is exactly point-to-point modeling? Well, this is actually not a common term in computer graphics. This is just my own term of naming a modeling technique that mainly uses vertices and edges first to create shapes, and then use that shapes to generate 3D meshes using different methods such as extrude, spin, bridge, etc. The downside of point-to-point modeling is that the resulting meshes tend to have normal problems. This is not a big deal. You just need to remember to perform recalculate normal every time you finish generating a 3D mesh from point-to-point modeling techniques. Now, because we are going to work a lot with only edges and vertices, and the default color of vertices and edges are black, we need a brighter background color to be able to see them clearly in the viewport. So go to the viewport option panel here and change this background color mode to viewport so we can use a custom color. Make it brighter at around 0.7 of the level value. And I want to make this a bit bluish. You really don't want to set the background color to be pure white because selected vertices will have pure white color also. Now, if you don't want to change the background color, that is totally fine. I need to do this so you guys can see the lesson better. The first thing we need to do is to have an object in the scene as the container for the vertices and edges that we want to create. There are 3 scenarios for this. First, if you're already working on an object, and then you want to add more mesh using point-to-point modeling, in this scenario, you don't need to create a new object. Just stay in the edit mode of that object and start modeling. The second scenario is that you need a blank mesh object. What I mean a blank mesh object is a 3D object but without any mesh data inside it. For this, you can just create any mesh object, for example a cube, and then go to the edit mode and just delete everything from inside the edit mode. The third scenario is you need to start with a single vertex at the center of the world and or at the origin location. For this, you can create a plane object. Go to the edit mode and then press X and then choose Edge Collapse. This will create a single vertex at the center so you can start working from this vertex. Now, because you only have a single vertex, you need to make sure that you are in the vertex mode the first time you edit it. Because if you are in the face mode or in the edge mode, you won't be able to see anything. Another way to start point-to-point modeling in the case of scenario 2 and 3 is to use the Extra Objects add-on. This add-on is an official Blender add-on, so you don't need to download it manually from elsewhere. To turn it on, simply open the Preferences panel, go to the Add-on tab, search Extra here. We can see there are 2 add-ons that are named Extra Objects. This one is the Mesh Object type, and this one is for the Curve Object type. What we need now is the mesh object type. So click on the checkbox to turn it on. And just close the preferences window here. Now, if we go back to our viewport and then press Shift-A, in the mesh submenu below the monkey option, you can see additional mesh objects that are not here before. We can create a round cube, different types of torus objects. We have gears, and you can even create 3ds Max style teapot object here. What we want to focus on now is this single vertex menu here. Under this menu, there is a Add Single Vertex option, which basically will create a new mesh object with a single vertex inside it. And this option, Object Origin Only, this will create a blank mesh object. For now, let's select this Add Single Vertex option here. We now have an object with a single vertex in the 3D cursor location. What's so unique about this Add Single Vertex command is that it automatically turns on the edit mode, which is nice. Now, let's discuss the basic techniques of point-to-point modeling. Press 1 in the numpad to go to the front view. Remember, we now have one vertex selected. We can see down here in the status bar, verts 1 of 1. It means, currently, we have one selected vertex out of one total vertex. If we hold Ctrl and then right-click here, then here, and so on, we are extruding the vertex directly to where we right-click the mouse. Basically, extruding a vertex means we are creating a new vertex with an edge connected to it. If you press Alt-A to deselect all, then hold Ctrl and right-click here, for example, Blender will create a new vertex floating alone. So again, if you already have vertex selection, Ctrl and right-click will extrude it. But if you don't have any selection, it will just create a vertex alone on the location where you right-click your mouse. Now, if we select multiple vertices that are not connected directly to each other, like this for example, hold Ctrl and then right-click, we'll get multiple vertices extruded. But if we have adjacent vertices selected, for example like this will actually select the edge connecting the vertices also. Because of this, if we hold Ctrl and then right-click, Blender will extrude the edges and so it starts creating some faces. You can also do this in the edge selection mode. For example, if you select this edge, hold Ctrl and then right-click here, and so on, Blender will create this ribbon structure. And you can see how it slightly corrects the rotation of the previous edge to create a smooth ribbon curve. Using this simple method, you can create roads quickly, or perhaps a path for a snake and ladder type of game, for example. Another method of extruding vertices or edges is by using the E shortcut. So yes, E shortcut can be used for extruding all mesh element types, faces, edges, and vertices. The biggest benefit of using the E shortcut is that we can create straight edges. For example, if we select this vertex here, then press E, we can see the vertex is extruded and we are now in the move mode. At this stage, if we want to create a horizontal line, we can press X on the keyboard. The movement is now constrained to the X-axis. We can then left-click to confirm. If we press E again, and now we want to constrain to the vertical direction, because we are in the front view, the vertical direction is Z, so we need to press the Z letter key. Now the movement is constrained to the Z-axis. Then we can left-click to confirm. Now, because using the E shortcut is actually an operation, we can always revise the distance or the location via the operator panel here. When using the E shortcut, you can also type in the value on the fly without using the operator panel nor using the mouse. For example, we want to extrude this vertex to the left for 2 meters. We can press E, then press X, and then -2, then enter. If you want to extrude this up for 50 centimeters, press E, then Z, then type 0.5, then enter. Now, if you don't like typing on the keyboard too much and prefer to use the mouse, you can actually constrain to any axis on the fly using the middle mouse button. For example, if I press E again, now we are in the free movement mode. In this condition, instead of typing the axis letter key, you can press and hold the middle mouse button. When holding the middle mouse button, you can choose to either constrain to X-axis or to Z-axis. After you choose the axis, release the middle mouse button and just continue placing the new vertex. Then left-click to confirm. You can also deactivate the constraint by using the same middle mouse button method. To show you what I mean, if you press E again and then hold the middle mouse button, choose the X-axis for example, and then release the middle mouse button, we are now constrained to the X-axis. Now at this stage, if you want to release the axis constraint, simply click release on the middle mouse button again. Now we are back in the free movement mode again. Using the E shortcut is great, but there is a caveat. Just like how we extrude faces, if you press E and then try to move this new vertex around, but then you change your mind and cancel it by right-clicking, you actually only cancel the movement, not the extrusion. So currently we have double vertices here. We can see this if we press G and then move the mouse around. So just remember to press Ctrl Z after right-clicking, so we also cancel the extrusion. Next, we are going to cover several more techniques for refining the shape of our edges and vertices. The first one is subdivide. If you have an edge like this, and you want to add more vertices on this edge, for example, you want to add 3 vertices along this edge. First, you need to select the edge. You can do this in the edge mode, like this. Or, you can also do this in the vertex mode by selecting this vertex here and this vertex here, okay? Now right-click and then choose Subdivide. In the operator panel, Just type 3 in the number of cuts input field. Now we have 3 new vertices on this edge. The next technique is connecting vertices. We actually have discussed this already, but I need to explain this again just as a reminder. If you want to create an edge between this vertex and this vertex, we need to select both of these vertices first and then press F. A new edge will be created connecting the vertices. Again, this is something you should already know by now. The last technique I want to cover in this video is vertex bevel. Let's say you have a corner vertex like this, and you want to convert this into a round corner. To do this, you can use the bevel operation. But the bevel operation we are going to use is not the edge bevel operation we have covered before. Instead, this is a vertex bevel operation. So if edge bevel operation use Ctrl B shortcut, vertex bevel operation use Shift Ctrl B shortcut. There is an additional Shift modifier key here. So again, make sure the vertex is selected, then hold Shift, Ctrl, and then press B. In this condition, we can move the mouse closer or further to define the bevel depth. And we can scroll the mouse wheel to define the number of new vertices created. And if we left click to confirm, as always, we can still revise the parameters in the operator panel here. Okay guys, so those are the basic techniques of point-to-point modeling. In the next several lessons, we will cover the methods that we can use to convert the shapes that we have created in the point-to-point modeling into 3D meshes.